So solve the system using Crammer. A, we have x minus y plus 2z is equal to 4. We have x plus 2y plus 2z is equal to 7. My eyes are scattered. Plus 3z is equal to 2. And then 3x plus z is equal to 4. So then what do we do to find so first thing, you write it like in the case of question 6. You first write this as Ax is equal to, say, Z, where A is a coefficient matrix, and then X is a variable matrix. This is a solution matrix. So you say you pick the coefficient of X first, 1, 1, 3. The coefficient of Y, -1, 2. And because there's no y in this one, it means this coefficient is 0. And then for z, 2, 3, 1. And then you write x, y, z is equal to 4, 2, 4. Then from here, we are calling this matrix A. So the first thing we do is we find the determinant of A. Determinant, the usual way of getting determinants. So we do, I pick one, put one here, and then cut this, remove that, then get the determinant of this, multiply here, minus this. So when you multiply, we get 2 minus 0, which is 2, and then minus from the invisible signs, and then pick the number -1. And then you cut here, you cut there. You get 1 minus 9, which is -8. And then plus 2. So here I meant when you cancel, we get -8. And then plus 2. We cut here, we cut here. Then we'll have 0 minus 6. Which is -6. So this is 2 minus, we get plus, minus, we have a minus, and then -12. So this is -20 plus 2, which is -18, like that. This is the determinant of A. Then 2, you get the determinant of matrix AX. The matrix AX is the matrix whose X coefficients have been replaced by the solution matrix. So you get these, substitute them where they are these, and then you forget about the y1 and the 1, 1, 3. So in that matrix, in the first column, we'll put 4, 2, 4. And then these two columns will remain as they are. -1, 2, 0, 2, 3, 1. Okay. Then we get determinant here. Again, we go for the first row, 4, then cancel, cancel. Then you get 2 minus 0. So we'll have 2 there. And then minus 1. And then cancel, cancel. We have 2 minus 12, which is minus 10. And then plus 2, cancel, cancel. We have 0 minus 8. So that is minus 8 there. Minus 8. So get 8 minus 10 minus 16, which is minus 18. 3, we get determinant AY. Now we go in here, the coefficient of Y, the coefficients of Y replaced by the solution matrix this time around. So the coefficients of Y, so we'll have 1, 1, 3. This time around, the X coefficients are back. We put them back, we replace the Y now. So 4, 2, 4. And then 2, 3, 1. And then do the substitution. So, I mean, we do the determinant again. So we take 1, then remove that. So we'll have 2 minus 12, which is minus 10. Minus 4, this 4. And then cut. Then we remain with 1 minus 9, which is minus 8. Then plus 2, cut. 4 minus 6, which is minus 2. Giving us minus 10 plus 32 minus 4. So we get 32 minus 10, that is 22, minus 4, positive 18. And then the fourth thing is to get determinant AZ. This time around, the first column, second column, we have them 1, 1, 3, negative 1, 2, 0. And then replace the third one with this one. Determinant. Again, we cut. Or this time around, let's use the third. Let us use the third row. This one. So remember, plus minus plus. So we have plus 3. And then we remove this and this. The remaining one will have negative 2 minus 8, which is negative 10. Which is negative 10. And then because of this 0 here, we skip. We go straight to the last one, 4. Then remove. So we'll have 2 plus 1, which is 3. So we have negative 30 plus 12, which is negative 18. After you get these determinants now, Crammer's rule say to get the value of x, you divide the determinant of ax by the determinant of a. Determinant of ax is this one here. I mean, is this one here, negative 18. And then divide by determinant A is this one here, negative 18. So here the answer is 1. Next, y, determinant AY over determinant A, which is determinant AY is 18 over determinant A, negative 18. So we get negative 1. Again, Z is determinant AZ over determinant A. Determinant AZ is negative 18, this one here, over negative 18 from here, giving us positive 1. And that's where matrices end.
So just a question. So sir, I don't know if I'm saying right, but it looks like that one, the solution matrix, it looks like it was traveling, like it went first row, second row, then, I mean, first column, second column, then third column. That's what you are doing, right?
Yes.
Then for the first column, you said AX. Then for the second.
Because what we removed were the coefficients of X. Remember, these are the coefficients of X, is it? 3, 1, 1. That's why we named it AX.
Okay, I get it. Thank you.
So the other question on Crammer's rule, that's an exercise for you to do. And exercises are submitted. So I was impressed. I received different solutions. But at least you solved. It was a good thing. Very good. Okay, so let's go into vectors now. So into vectors, I'll start by doing addition and subtraction of vectors. So all the examples we are getting from the Tutorial sheet. Question 8 as an example now. Given U is equal to 4J minus K and V is equal to 6I minus 2J minus 7K. Compute A. So this we're also doing scalar multiplication. So we have 3 over 4 u, 3 over 4 multiplied by vector u. So here what you do is you have 3 over 4 and then multiplied by the vector 4j minus k. This is normal multiplication. So 3 over 4 times 4. So you do 3 over 4 times 4j minus 3 over 4 times k. So the 4s will cancel. So you have 3j minus 3 over 4 k, like that. And then b minus 3u minus 7v. So this, again, you bring u 4j minus k minus 7, and then get v 6i minus 2j minus 7k. So you multiply negative 3 times 4, you get negative 12j, negative 3 times negative k, we have positive 3k, minus 7 times 6, we get 42i, negative 7 times negative 2, positive 14j, negative 7 times negative 7, positive 49k. And then what next? Well, you add each component to respective component. So here we don't have I. The only I we have is here. So we'll start by writing 42i. So like terms, like terms. Then minus 12j plus 14j. So you're doing, becomes plus 2j. And then 3k plus 49k, we get 52k. And we're done. So when we add or subtract vectors, you get a vector. Like that. Now we talk about the magnitude. The magnitude of a vector. So if you are given a vector v, ai plus bj plus ck, the magnitude of vector v is equal to the square root of a squared plus b squared plus c squared. You leave out the components I, j, k. An example is coming from question 8C of the tutorial sheet, where we are asked to find the magnitude of v plus 10u. So first we find v plus 10u as a vector. So what is v? V is 6i, it's this same v and this same u, minus 2j minus 7k plus 10u. Hello.
I'm lost.
Uh-huh.
Why you've written magnitude if vector v something something. That was just is it a formula or maybe you
Yeah,
are trying to tell us something?
this is the definition of the magnitude. This is the formula.
Oh, okay. Then the example, where is it starting from?
Oh, the example is
Yes.
8C. So
Okay.
8C, since this is question 8, is it?
Yes, sir.
And then we have A, B. Now C says compute the magnitude. When you see these lines, it means the magnitude
Okay.
of V plus 10U.
Yes, sir.
So now we're saying for us to find that magnitude, we first need to find the V plus 10U as a vector.
Okay. Yes.
That's where we are now.
And then where is this 6i minus 2j minus 7 coming from?
As the matrix, as a vector V that we have here.
Are we substituting in short?
Yes, because we're just given V plus 10U. So you pick the
Oh,
V plus 10U.
okay, now I get it. Thank you.
Okay. So you get plus 10. What is U? U is 4J minus K. And then this is 6I minus 2J minus 7K plus 10 times 4, we get 40J minus 10K. And then we put together those components. 6I negative 2J plus 40J, we get that 8J. Negative 7K minus 10K, we get 17K. Then now, the magnitude of V plus 10U is simply the magnitude of this now, which is defined as the square root of, pick 6 squared plus 38 squared plus minus 17 squared. So that is like 6 squared plus 8 squared plus negative 17 squared. So we get the square root of 1769. Like that. Okay, so this video can end here. So that we
So
start another.
previous slide page.
It's there.
Right, thank you, sir.
We are done with the class, huh?